Hello everyone, welcome back to MindMatrix. In today's video, we'll be solving a few problems. Okay, so I hope in the last video your basic concepts are clear. We had a sample question as well, and I told you there was an axiom. Okay, so sorry, there was a corollary which I asked you to prove. So we'll be having a look at that as well. But before starting, today's session is going to be very interesting because we'll be seeing three questions which are of a good level. Okay, and you won't be requiring any higher mathematics for that. Okay, that is just basic probability. Even on the basic probability, how we can get some good question, you'll get to know this today. Okay, and at last there will be a homework question for you guys so that you can get to know that whether you have understood the topic or not. Okay, whether you can solve such kind of problems or not. So today's session is going to be very important, and if you are getting some value, do like it, comment down below. Okay, your learning and how are you feeling about these lectures. Okay, and share it with your friends who are preparing for GATE data science or computer science. Okay, so let's move further towards the topic of the day. So here is a quick intro about myself. Let's skip that, you already know. So now, so from the last class, first of all, we'll prove the corollary what we had. Okay, so let me just tell you what exactly was that. So I asked you to show this thing. Okay, that P of A union B, what is this? That you must know this like from your childhood, basically whenever you started understanding set theory and probability altogether. So the answer is going to be something like this: probability of A plus probability of B minus probability of A intersection B. But how do you get this from the basics? Okay, so that was the point. Though it will not be asked in your exam, but you should be knowing the basic around that, because the proof also doesn't take so much of time. So it is important that how axioms are being used over here. So you remember that point when I asked you that, okay, if we have some disjoint sets, okay, a number of disjoint sets, and if we are asked the union of disjoint sets, okay, probability of union of disjoint sets, because I hope you remember that whenever I'm talking about events, sample space, all those are nothing but sets only. Okay, all those are nothing but sets only. So if I want to calculate the union of a number of disjoint sets, the point is the sets has to be disjoint. All these a1, a2, a3, a4 up to whatever it is going, all those must be disjoint. That means nothing is common in between them. Then we can write it as sigma probability of individuals. Basically I can then write it as summation of individuals probability. That is, I can write it as probability of a1 plus probability of a2 plus probability of a3. Okay, these are not the questions I'm going to conduct today. Okay, this is the last time's homework which I asked you to do. Okay, today's questions are very important, very tricky, very conceptual. You'll be enjoying that for sure. So this is the basic. Around this only you'll be able to solve this. So if you have something like, let's recall the Venn diagram. If you have something like this, okay, this is A, this is B, A and B. So like if I want to break, there is this common portion, and if I want to calculate, the sets must be disjoint. If I want to break this, break this union, the sets must be disjoint in that case. But are A and B disjoint? The answer is no. They are having this common portion which is called A intersection B. So let me break it. So I will call this part as simply A minus B, or which can be also written as A slash B. Okay, just this is important. Both the notations are same. And I will say this part, only this part, the separate part, to be B minus A, which can be written as B slash A. Okay, so let me just show you with the help of colors what I'm talking about. So this is my basically portion A intersection B. Okay, this is, I'm talking about A minus B, this portion, this complete portion. Okay, this is my A minus B, and this one, and this one is my B minus A, or simply B slash A. Okay, so now they are disjoint. Now they are disjoint, nothing is common in between them. So now I can write what, as I gave you the hint as well, that now I can write P A union B as, because I can break it, P of first part is this A slash B, which is nothing but A minus B, union A intersection B, which is like the middle part over here, and then union B slash A, which is nothing but B minus A I'm talking about. So now we have three disjoint sets union, and now I can break it. So what I'll be getting? P A slash B. And there is an important point over here which I would like to consider so that you don't get confused. Plus P of B slash A. What is the important point I'm talking about? So you must not be confusing this with respect to the conditional probability that, finding out P of A given B, probability of finding A given B. That is not this thing. Okay. Here is just the notation which is coming out to be same. But over here, this is representing the set difference A minus B I'm talking about. Similarly over here, this is not the conditional probability I'm talking about, that is B given A. This is I'm talking about only B slash A, which is B minus A. I hope the idea is clear over here till this point. Okay, so I could break this into these three parts. Now now what I wanted at last, I wanted in terms of individual A, B and common whatever was there. So we have some kind of common idea, and we have some separate this part and this part. How can I solve that? So combining this, I can get probability of A. This is disjoint. If I can combine, I will get P of A. Okay, just reverse of this, okay. So for this to be completed, I need again A intersection B, but I had only one. Okay, so what I can do, I can simply add and minus probability of A intersection B. I have added it once, and minus probability of A intersection B. Adding and subtracting same quantity does not change my equation. Adding and subtracting same quantity does not change my final value. Okay, so I have done that. So now just tell me, from the basic only, I'm talking about this. Okay, from the basic only, and you have already learned it as well, that what will this be called and what will this be called. We have seen now that, okay, that individual disjoint sets union can be broken down into sum of individuals probability. So if I would like to add, provided they were disjoint, I can combine it using their union, So this was only A minus B, which was green part. And if I add this disjoint part, which is like red part, what do I get? I get probability of A. Similarly, if I'll add this, adding this part to this, so these were disjoint, so adding this, I will get the union of this. What is that? That is P of B. And what I'm left with, minus P of A intersection B. We had the proof. Simple. I hope the idea is clear. So that was the proof you had to do in your last session, okay, which was the homework. So I hope the idea is clear. So now we'll move on towards the good questions I was talking about. So there are only 3 questions as I mentioned, and these are really good. You'll enjoy these, okay? So let's see that. So yeah, here is the first question. Okay, very important. You need to understand first of all what is the sample space and what is the event, because whenever I'm talking about the probability, the basic terms, because we have not introduced the concept of random variable yet. Okay, we have not introduced that. So till then we have to talk about only event and sample space, whatever we are having. Okay, so the question is the base and altitude of a right triangle. Right triangle means basically we are talking about a triangle which is having one of the angle as 90 degree. This is the right triangle. Okay, so it is being told that base and altitude, basically this is talking about the length of base and altitude of a right triangle are obtained. We get that by picking points randomly from this and this range respectively. So that means for base, I will be picking up any value in between 0 to A, and for altitude, I'll be picking any value between 0 and B. Okay, and then I'll be creating a right angle triangle. So what does this thing mean? Let me show you properly with the help of some diagram. Okay, let's go. So something like this, and let's say this is A, this is origin, and let's suppose this is B. Okay, so over here on this x-axis, I'm talking about the base length. Okay, and on the vertical axis, I'm talking about the altitude possible for my right angle triangle. So now my base can be any value between 0 and A. any value between 0 and a. So let's say the value is this one, which can be anything. Okay, and the altitude value also can be any value in between 0 and b. So let's suppose the value is this, as this is less than b and greater than 0. So in that case, what is my right angle triangle? So this is my height, altitude, and this is my base in that case. So what is going to be my triangle? Something like this. I hope the idea is clear. So I can have right angle triangle, or basically right triangle, based on the value of my base length and altitude. So there are number of what? There are number of right angle triangle which are possible. For an example, if my A was this, sorry, if my base was this only, but I change the altitude, I can get this right triangle, I can get this right triangle, I can get this right triangle as well. Okay, I hope the idea is clear. If I change this, the base, I can get this right triangle as well. Considering this to be altitude, this can be my right triangle. This can also be my right triangle. So you can see, for each corresponding base and altitude value, I can have a different right angle triangle. Okay. The point is important to understand how triangles are getting formed. Then only we'll be able to understand further that, okay, what we need to calculate. So the idea over here is that how we are creating these length. One is base and the other being your altitude. It is not writing. Oh, everything gone. Yeah, fine. So I hope the idea is clear. So basically, if I just draw it just once more to just show you the examples. Okay, to just show you the examples. If this is 0 to A and this is 0 to B, so what are the possible triangles I can have? Okay, I'll try all the triangles which I can make. The triangle can be this. Okay, the triangle can be any of these. Okay, considering any length, the triangle can be this as well, because the base is in between this only and the height is also in between this. Let's talk about some other one. Okay, if I just take something like this. Okay, let's take the height to be completely this B. So this is also the valid right triangle I'm having. Similarly, something like this I can have. Okay, this is also the correct right triangle. So further, like we can go like this, like any number of times. Okay, so the point is, I will be picking my base from 0 to A. I'll be picking my height or altitude from 0 to B, and then I'll be getting some triangle. Okay, so now you have got the idea that what are we talking about? The triangles, right triangles, and how these are getting formed. Now the next point is, what is the probability that 3 line segments, oh sorry, we have come to some different problem. This was the one. Okay, it's okay. So I guess you are clear with this. Okay, you can just create this kind of diagram for understanding the same second question. Okay, because first question we have done in the last class, so that's why the numbering we are having over here. Okay, so you can consider this diagram for this problem. We'll be coming to this problem as well. Okay, so I hope this idea is clear, that how my right triangles are getting formed. So now I'll just erase all over here. Now I'll talk about the next part. So we have got to know that how we are creating the right angle triangle. Now we have to find the probability that the area of the triangle so formed will be less than AB by 4. Now we are talking about that as we have a number of triangles over here. See, the example is still present over here. We are having these many triangles. So there can be number of triangles present over here, right triangle. So we have to find out the probability of those triangles which will be having area less than AB by 4. It is being mentioned. Area must be less than AB by 4 for all those. Are all the triangles having area less than AB by 4? The answer is no. Simple. The biggest one, if I talk about the area of the biggest one, would be complete B and complete A. If I consider base to be A complete and altitude to be B, what is the area of triangle? For right angle triangle, it is base into altitude, half of base into altitude. So it is going to be A into B. So AB by 2, which is like greater than what we have, that is AB by 4. So we won't be having all the triangles greater, having area greater than AB by 4. So the question must be clear till this point. question must be clear till this point. That what are we talking about? What will be the triangles which will be getting formed? And are all the triangles will be having this area? The answer is no. So we have to find out those triangles which will be having less than AB by 4, area less than AB by 4, and then we calculate the probabilities of those triangles. I hope the point is clear. The question is clear till this point. Now one by one we'll calculate each of the part. So you have got the idea of question. What are the triangles we are talking about? Now let's talk about the sample space first. Let's talk about sample space first. What is going to be our sample space? So see, there will be a difference coming over here based on the understanding which we will be having. So I'm talking about right now that my base, let it be on the x-axis, okay, on the x-axis, that can go from 0 to a. If I talk about the altitude, which is on the y-axis, that would belong from 0 to b, that would be in the range of 0 to b. The point is important over here, okay, 0 to b. Now how many triangles are possible? So it is equivalent to, like, what is the number of points present within this, if I consider x to be in between 0 to a and y between 0 to b. So what is going to be the total number of points which are possible? So rather than counting points, what we can do, the area, yes or no, we can have an idea of area over here, as we did in the last class, that if we can't count the point within each of the area present, and if we are able to calculate the area directly with the help of our mathematical simplicity, then that is better idea, I guess. So rather than calculating each of the point, like counting, the better idea is calculate the area directly. So what would be the area if I say that, okay, x belongs to 0 to a, both the points are included, y belongs to 0 to b, both the points included, okay. X is, I'm talking about base, y is, I'm talking about the altitude. So what is going to be my total possibility for x and y? So it is like, you are having this length, this breadth. What is going to be my area? I'll talk about the confusion. I know, like, what can be the confusion. So area will be a into b. Now you'll be telling that just before that you were talking about the triangle. Now you have created a rectangle. What the hell is going on? The point over here is simple. Earlier we were showing you what is going to be my triangle after picking the a value and b value, after picking up a value and b value. Now I'm talking about that, okay, what are the combinations of a and b possible to have the triangles within this area, within this range. Okay, if I pick any value between 0 and a and any value between 0 and b, what will be the points or coordinates possible? For that we have to calculate the area. For an example, if I talk about this thing, okay, this will give you a good idea that, okay, if let's suppose this is something like 4a by 5, okay, this coordinate is 4a by 5, and let's suppose this is something like we can say 6a by 7, sorry, 6b by 7. What I'm telling you is, let me just write it clearly, okay. I'm saying, just erase it first, okay, let me just create this part. I'm saying that let the point be on the x-axis, that is base I'm talking about is 4a by 5, and let the height be what, 6b by 7, 6b by 7, 6b by 7, okay. So what is the coordinate I'm talking about? Coordinate is my 4a by 5 comma 6b by 7. So this is the coordinate I'm talking about. So all the coordinates present within this area will tell me exactly, the x part will tell me what is the base, and y part will tell me what is the altitude, and corresponding to that I'll have a right angle triangle. For an example, for this one, what will be my triangle? Triangle would be something like this, okay. If I consider any point over here, the triangle I'll be considering over here would be something like this. If I'll talk about the same one, it would be like this. So it is just something I'm talking about the coordinates possible for my base and altitude, the value of base and altitude possible. Corresponding to that, the area would be simply half of what is the base over here for this one, 4a by 5 upon 6b by 7. And we'll get the area of corresponding triangle, right triangle, for which my base is this and altitude is this, which is given by this coordinate mentioned over here. So basically, how am I getting these coordinate? It can be any value from 0 to a for base, and for altitude any value from 0 to b. I hope the idea is clear till this point for the sample space. So what would be my sample space? Sample space would be nothing but area of coordinates possible, area of this region, basically complete region, area of this complete region. What is that? That is nothing but AB. I hope the idea is clear till this point. How AB? It was just what? It was just a rectangle with my, length to be A and breadth to be B. So I'll just multiply, I'll get the value. That is area of my this rectangle, which will show me what are the total number of points possible within this area. So the sample space is AB. Very important to understand. Sample space is AB. That's it. Area of this portion, which is marked by red, that is AB. Further, we'll talk about the event. Now we'll talk about the event. Okay. So let's see that. So I hope this idea is clear. My sample space is the area of this portion, which is AB. I'll just remove everything now. So let me just write that. What we have done till this point, we have talked about the sample space, which is what? Sample space is area of rectangle, which is what? AB. That is the area I'm having. Now for the event, what is the condition I'm having? The area must be less than AB by 4. Area must be less than AB by 4. So just the same thing. If we had something like this was A, this was B, considering, base to be on x-axis and this to be on y-axis. So I can consider any point to be like, the point is, any point would be within this only. Okay. So let's suppose any point I'm talking about is x comma y. So for that, the base I'm talking about is x, the height I'm talking about is y. So corresponding to that, what will be my area? What will be my area? The area will be half of base into height. So that is, if I say x is my base, y as my height or altitude, okay, altitude, the area I'm concerned about is going to be half of xy. And I am saying that area of any triangle which I'm looking for, okay, area for which I'm looking for must not be greater than AB by 4. That means it must be less than AB by 4, less than equal to AB by 4. The point is this. So that means I have reached up to the point of xy must be less than equal to AB by 2. This is important equation which must be satisfied to get the area less than AB by 4. Okay. And we already know the other conditions we are having. Other conditions are x must be between 0 and A and y must be between 0 and B. One condition, two condition, and this is the third condition for my event to be true. Okay. For my sample space, what were the conditions? Only these two were the conditions. For sample space, only these two conditions were there. That okay, my base would be 0 to A, and my altitude will be from 0 to B, and then whatever triangles are forming, all those triangles are valid. Okay, those are the triangles I'm considering. Now for the probability, what kind of triangles I'm looking at, whose area is less than AB by 4. So we have created this extra condition for my probability case, that okay, for the triangles which must be having area less than AB by 4. So this is the important criteria. Now to be honest, you must be knowing. If you don't know, then it is still fine. What exactly it is representing? What exactly it is representing? It is representing a hyperbola. If you don't know, it's okay, still fine. But you must be knowing this fact that okay, if something like this, I'm not talking about the inequality. Let's talk about this thing only. Xy equals AB by 2. This represents the hyperbola. So you can simply see over here, if I put what? Anything, let's suppose, what should I say? It's like y equals AB by 2x. I hope now this is clear. So to get the idea what is the shape I'm talking about, if you put x equals infinity, y must be 0. That means it would be something like this, touching, when x is infinity, y is 0. So it would touch 0 at infinity. And when x is 0, at that point of time, y will be infinity. So it would be something like this over here. So something like this. This is going to be my hyperbola on the first quadrant, but x and y can be negative as well. So if x is negative, y will also be negative. If y is negative, will also be negative. So it will be same shape would be present at this quadrant if I just extend this. Okay, so this is not required, but I'm just talking about this for your extra knowledge over here. Okay, so this is representing some kind of parabola, sorry, hyperbola, if you don't know. Okay, so up to this, the idea is clear that, okay, I'm having this kind of extra condition which is present over here. Now I'll just talk about this thing. So to be honest, to find out all the values for which this condition will hold, you must be knowing that xy is less than equal to ab by 2. And I know that this kind of curve is present. I know this kind of curve is present. Okay, and I already know the sample space is in between that. The sample space is all the points within this rectangle I'm having. Okay, now just to find out that which side I must be talking about, the triangles which will be having less than ab by 2 area, which side I must be talking about for this curve. It must should it be um, below this curve is like this. I'm talking about whether it must be at this side or at this side. For these kind of things, you already know, you have already studied. Most of the time you will just put 0 0 to find out whether that is correct or not. If 0 0 lies in that, if 0 0 is true, by considering those points, then what you'll be getting, then that means origin lies in that particular area. So for an example, if I simply put 0 0 over here, then 0 less than equal to ab by 2. Is that true? Yes, because a is also positive quantity, b is also positive quantity. 0 less than ab by 2 is this equation holds true. That means 0 0 lies below this. Okay, 0 0 lies below this part. I hope this idea is clear. If it would have been negative, that means 0 0 lies on the other side. If this is getting satisfied, that means 0 lies 0 0 in whichever area it lies. That is the condition which is present over here. Okay, that is the area we are talking about, in whichever area my 0 0 is coming. So that means I would be talking about only this part. So I'll just erase this. That means if this is my hyperbola, which is like represented by this, so I'm talking about the area below that only. So if I just clean this up, what will I be getting? I'll just show you that now. Okay, if I just completely clean this mess over here. Okay, yeah, if I just clean this mess, what I'll be getting is, I'll just talk about that. Okay, whatever it was. Okay, I'll just write it also properly. Okay, I'll just erase these things. Okay, I cannot erase all, that's why I have to do it like slowly over here. Yeah, so the extra equation which we have over here is this one, that xy must be less than equal to ab by 2. Okay, that was the extra equation we are having. Okay, and if I talk about the curve, now the point is about the curve, okay, which we have to talk about. So it was like this. So this is my a, this is my b, and this was kind of curve I was talking about. So this is basically the curve equals, which is xy is equal to ab by 2. This is the curve I'm talking about. Okay, so that would be cutting these lines somewhere. Okay, so what I need to do over here, how can I calculate? So I have got to know this thing for sure, that my x and y must be from 0 to a. For this also, like for all the triangles, the area where I'm requiring it to be less than ab by 4, I know that, okay, x has to be between 0 and a, y has to be between 0 and b, and other than that, my those triangle must be following this condition. That means if I have already put up this 0 0, to understand that okay, where does 0 0 lies within that. 0 0 was satisfying, so that means in whichever 0 0 is, that is the area I'm talking about. So that must be within this region. So if I talk about my actual points which will be generating this area less than AB by 4 are all those points which are lying in this particular area, in this particular area. You know, it cannot go below this because it has to be greater than 0. It cannot be greater than B, cannot go beyond A, cannot be less than 0, the base. Okay, so that means I am talking about all the points over here now. And you know what was your sample space? Sample space was complete rectangle, and now I'm talking about just this portion. I hope the idea is clear. So I have to calculate this area. This area will not be giving me the area of triangle. Okay, this area is giving me, it is telling me about the number of points present which will be having area less than AB by 4. Like for an example, if I pick any point within this region, let's suppose the point is present over here, then whatever would be the x coordinate, let that be x. Whatever would be the y coordinate, let that be y. So if I create a right angle triangle with that, the area would be definitely less than AB by 4. That is what I'm talking about. Okay, and if I pick a point over here, then for sure it would be following the condition, okay, that area is going to be, sorry, the base is going to be between 0 and A, and height is going to be between 0 and B, but the area will not be less than AB by 4. It will be definitely greater than AB by 4 if I talk about the portion present within this region. This is what we don't need. We need only the red area over here. So I hope now the idea of your event clear, that what exactly area you are looking for. Okay, so this is a good question. I'm still telling you, that's why I'm spending enough of time for each of the question. So I guess, yeah, half an hour is already gone. Okay, but still we are not done with the first question we are having over here. So up till this point, I guess everything is clear, and you have to find out now what are these point and what are these point. Okay, the y coordinate of this is B for sure, because that is lying on the y equals B line, and x coordinate for this point is, you already know, that is A. What is the B coordinate, y coordinate you are looking for? Okay, so that then you can calculate the area between that. How you can calculate the area? You will do simply partition stuff. So this is again a rectangle over here, this is again a rectangle over here, and what is this portion? What is this? This is area under this curve. This is area under this particular curve. Okay, we will calculate this area by using integration, and we know this area by simple area of rectangle. So if I talk about, I have divided it into two parts. Let me just talk about that, which pen I can use. We have, yeah, I guess white is best. So this is the first area I'm talking about, and this is the second area I'm talking about. So the first area, what is the value of that? That is simply, okay, first of all, we have to find out these x and y value over here. So just tell me, what is this x value over here and what is the y value over here? This curve was satisfying this equation. We have already talked about that in enough of length which was required. This curve follows this particular equation. So if I put y equals B, I'll get the x coordinate, which is nothing but A by 2. So this is A by 2. Okay, and if I talk about this one, I know over here x coordinate is A. So what is the height I'm talking about over here? What is the height I'm talking about over here? So just put x equals A would cancel, y equals B by 2. So the point over here is B by 2. Okay, I hope up to this everything is clear. So what is the area of first portion? So if I talk about this length, this is A by 2, 0 to A by 2. And what is the height over here? B. So the area of first part is A by 2 into B. Okay. What is the area of second part? That we need to calculate. How do we calculate of area second? How do we calculate the area for that? So we know the equation. Okay. We know the equation. How do we calculate the area for that? We know the y equation. Y equation is nothing but AB by 2x. This is the equation in terms of x. Y equals AB by 2x. Now to calculate the area, what do we do? In area under the curve, what is that? Integration of AB by 2x, okay, dx. X will move from what to what? From which point to which point? We need to calculate second area. So x will move from a by 2 to a. From a by 2 to a. Okay. A by 2 to a. So what is the answer you will get? AB by 2 would be coming up outside. What is this thing? 1 by x dx. A by 2 to a. What would be this thing? So the integration of 1 by x is log x. So this is AB by 2 log x, and the lower value I'll be putting is a by 2 and the upper is a. What do we get? So yeah, AB by 2 as it is. What I'll be having? Log a minus log a by 2. Now just tell me, when we have something like log of m minus log of n and the base are same over here, okay, what do we have? We can write it as log of m by n, okay, the same thing. So it would be log of a by a by 2. Basically, what is this thing? We get it as log of a on the numerator, and in denominator we'll get a by 2. A would get cancelled and this will come over here. So this will be log 2. So what do we get over here? It is AB by 2 log 2. So the area of second part is AB log 2. AB by 2 into log 2. I hope this is clear. So that means the area of first part is AB by 2. Area of second part is AB by 2 log 2. What is the combined area? Combined area for my required event, whatever we are talking about. Okay, let's say this complete area to be E. Okay, what is that? That is simply addition of these two. So AB by 2, if I'll take common, so it will be 1 plus log 2. 1 plus log 2. Okay, this is the area. And what was the area of my sample space? It was area sample space was AB. So what I'll do at last, it would be numerator would be area of E, denominator would be area of S. What will be the answer? AB will get cancelled. So where can I show this? So yeah, there is not enough of space here, but I can this is the space I can utilize over here. So it would be AB by 2 1 plus log 2, denominator is AB. AB gets cancelled. What do we get? The answer is 1 plus log 2 by 2 is the final answer. That is the answer you are getting. Okay, so that's the probability. I hope the question is clear. So let me give you a brief understanding of what we have done. Okay, let me give you a brief understanding of what we have done. The thing is, we were given that what would be my base length. It would vary from 0 to a for a right angle triangle. It was given that what will be the value of my altitude. Again, it was a value between in the range of 0 to b. So I can create a number of triangles with that. We have already seen that. We have that even because I have not, I guess, yeah, this was the example we had it. Okay, so we can create enough number of triangles with that, right triangles with that. Now I was asked that the triangle so formed will be having area less than AB by 4. The probability of triangle we are forming having area less than AB by 4. So for that, what we had to do, these two conditions were already there for my any triangle I wanted within this range. So that made my sample space. Now for my area to be less than AB by 4, I made an extra equation which must be followed. So we created this thing. Okay, and then what we did was we simply find out if we know the curve, it's fine. Okay, or we can simply put some values to get the idea that what kind of curve I can have. Okay, the idea was simple, that if I put y equals, if I don't ignore just inequality, that less than part, If I write xy equals ab by 2, and I find out what is the value of x for a given value of 5, you will get, okay, what exactly a kind of curve I'm getting. We can use two extreme value and two in between values to find out that. Okay, then we got to know the curve is something like this. Curve was something like this. Okay, and then what we did, we had the curve, we found out that, okay, which side I'll be having the coordinates which will be leading to area less than AB by 4. Which side I'll be having? Would it be above this curve or below this curve? So for that, if I put within the inequality the coordinates of origin, and if that is satisfying, that means origin lies in that particular area where this equation is holding true. Okay, so when I put 0 0, so as it was true, that means 0 0 lies in that area where I want to calculate this, that my area must be less than AB by 4. So that means below this part. Now with these extra condition, I got to know that this is within this bounded area only. Within this bounded area, I'm having those points which will be leading to base value something, at altitude value something, and then area getting less than AB by 4. Okay, so now what was needed to be done at last? We wanted, for the sample space, we calculated the total number of points possible. How to do that? How do we calculate that? By finding simple area of that. What was that? That was the rectangle for the sample space. We calculated the area, that was AB. Now for this one, how do we calculate the area? So we split into two parts. First one was simple rectangle. The second part was area under this curve. First part, we got, what was this thing? A by 2 was this length and this was B. How do we calculate this x coordinate and this y coordinate? By simply putting the values, because I know this is y equals B line. I know this is x equals A line by default, because x coordinate is A. So this complete line would be x equals A only. That is just basic maths. And similarly for this was y equals B. So I got to know what is the y coordinate at this point, what is the x coordinate at this point, by simply putting those values. Okay, we have done that. So I got to know what exactly were the coordinates, what are these coordinates and what are these coordinates. Now I wanted to calculate the area of this second portion. So I simply did the integral calculus. Basically, to find out the area under the curve, I did integration. What was the integration? I converted y equals AB by 2x and then moved x from A by 2 to A. That was this thing. So we got this answer. And then I added the area of 1 and 2, which was this. And then area of rectangle was AB. So I got this. Okay. So we have solved only one question, and this is like already 42 minutes have passed. Okay, what I can see. So the next two questions I'll be, I guess I need to make separate videos for each of these questions, because these are good questions and that will require enough understanding for your, to get the basics correct, to know how to calculate these. Then only you will be able to solve good question in your GATE exam. And for this kind of question, you don't really need some extra concept like, okay, some kind of Bayes theorem, some kind of random variable. No advanced topics are needed. It was just basic thing. It is just the application part, that to what extent we can go up to. Okay, so I'll just split all these sessions into three parts, because there are three questions. I can show you these three questions. One is this, second other is this, and then this was the homework I was talking about, but it's fine. We'll do that in the separate session. So the point important over here is, we'll meet in the next session where I'll be solving this third problem, and then another where I will be solving this fourth problem. Okay, so see you guys in the next session. And if you're finding it valuable, if you're finding this session important, though the concepts, the concepts are not difficult, though the problem are maybe some difficult problems are present over here, but if you're able to understand how we are doing it, please give me a thumbs up. Okay, comment down below that how you have got this, whether you're getting the idea how we are solving it, because these kind of problem would be asked. It won't be like simply earlier problems like you have solved in 11th or 12th or in your B.Tech exam, as it requires some good mathematics or some good analytical skills. So yeah, that's how we have, for this data science paper, some good kind of questions which can be there. Okay, so thank you guys. Give me a thumbs up, share it with your friends, do comment down, and see you soon in the next session. Thank you guys. Okay. So yeah.